My name is Kyle Kotowick, and I'm here to talk to you about passwordless cloud architectures. A bit about me and my background. I did my PhD at the Massachusetts Institute of Technology, where I specialized in aeronautics and astronautics. Nothing to do with security, but I did that while I was also working in the Computer Science and Artificial Intelligence Lab, which is this silly-looking building. But there is some really cool research going on in there that I got to be a part of, some of which is security-related, just general computer science work overall. And when I finished that in 2018, I then went and started my own company, Invicton Labs. We do a lot of AWS cloud design and architecture and implementation, some IoT, some software and hardware design for everything from startups to the federal government. And we're based in the beautiful national capital of Canada, which is Ottawa. My house is right there in the middle. And a lot of the work that I do for my clients is on, how, like I said, how we develop cloud infrastructures. And a lot of the times I'm brought in onto a project to help redesign something, to redevelop something that hasn't worked well or that needs to be changed. A lot of my clients are startups that have just hit their Series A funding, so they have some sort of prototype, they have something that's ready to go to the market, they just got a bunch of money and they say, okay, darn, now we need to make it actually production worthy. And that's what I help them with. Does this look familiar to anyone in the room? First off, how many people here actually work with AWS in particular, just out of curiosity? Okay, so about a third of you. And cloud architecture in general? Two hands, about half, a little more. Okay, good. So this is something that we see all over the place. And in most of the clients I've worked with, I've seen something like this happen. This is a contrived example, because I'm not going to share this from one of my clients. But this is extremely common, people sharing things like passwords in plain text. And it really kind of highlights why there's an issue in the first place and why we need to talk about this. Now, for the purposes of this talk, let's define what I mean when I say password and passwordless. What is a password? And I'm defining that as any value that is used to authenticate or authorize with a system that is provided to the authentication system as is. So it in itself is the secret. It doesn't need to be decrypted in order to be used, so there isn't a different secret needed to use it. Or it's something that's used to generate or derive a value that's used to authenticate, such as secure remote password protocol or any kind of key derivation function. And this includes a lot of things that we might not always think about, right? So obviously there's your classic passwords, but also any kind of API key that you use to authenticate to a system, any kind of one-time token that has a long lifespan, SMS or email, one-time passwords or magic links. If you use Slack, you know they love to use magic links. Those are passwords, really, because you just click it and you're good to go. And unprotected certificates. So any certificate that doesn't require being unlocked with a password, that is a secret value and therefore a password for the purposes of this talk. And how do they leak? Well, we know that, well, passwords leak a lot, but how does that actually happen? Probably most often something like this, which we just talked about, but there are many other possible causes. CI/CD is a big one, and it's been in the news a lot the last few years. Does anyone remember this little issue, this little incident? CodeCov, one of the providers of code coverage testing, they had they allowed someone to modify the bash script that was in one of their upload tools, and that occurred in January 2021, and it wasn't discovered until April of 2021. That's a very long window for a lot of credentials to be breached, and that affected over 29,000 clients, which included HashiCorp, Mozilla, Twilio, and Rapid7. So major issue there. Travis CI had something kind of similar happen not too long ago, where a bunch of their credentials were logged out to plain text and could be accessed through APIs and stuff, and it's been a long-running problem. We have password managers, which we love to tout as the solution to password management, right? Because just use a password vault that you can share and everything's fine, except it's not. KeepPass had a known CVE where passwords were written out in plain text to the system log. That's not very secure. Lots of different things can access that. LastPass, this one's got a lot more media attention, where attackers got access to the development environment and were able to access a lot of stuff in there. And LastPass is very adamant that nothing was actually breached because they don't have production data in their dev environment, and because even if they did, it's all encrypted with a secret only the client knows, and so they can't unlock it if they want to. But it still shows how these systems that we think should be very reliable can still quite often and easily be attacked. The other thing about password managers is we get a situation like this. It requires manual intervention to make sure that it remains up to date, right? And so we terminate someone's employment or we move them to a different department or job where they shouldn't have access to something anymore. Who's responsible for actually making sure that all the credentials they have access to, all that's revoked or updated appropriately? And quite often it just doesn't happen. We have passwords that get stored locally and never rotated. So anyone who's worked at AWS probably recognizes this file. This is a credentials file. As per AWS guidelines, it is stored in plain text in my home user directory. And when you're someone like myself who works with a bunch of different clients and usually in a role that has administrator access to everything, this one file could give you administrator access to the root AWS accounts of 10 different enterprise companies, right? This is a major security issue. Certificates, especially if they're not password protected, this is a secret. It's stored locally. It gives you access to something, and it's rarely rotated, maybe once every couple of years at best. We can have simple passwords. So even if a password isn't available somewhere, if you can guess it, if you can brute force it, well, now you've retrieved that password, and you can use it for other things, especially in the modern day of GPU. Like I have, my 4080 GTX RTX can do, I think it's like 50 billion hashes a second it can attempt. So simple passwords. These are the most common ones in 2022, with password being detected 5 million times in online leaks. And these get incredibly expensive. So this is showing the number of client records that are leaked against the cost of that. And we're getting into the hundreds of millions of US dollars for this. And that seems extreme, right? No one actually has to deal with that. Does anyone remember this one? T-Mobile, $500 million settlement in 2021. What happened here, and the details on a lot of these attacks, as you all know, are quite sparse, but the attackers were able to access the internal network through a misconfigured gateway, and that gave them access to a test or development environment. And from there, they were able to brute force their way into production data. So essentially, our theory is, although T-Mobile hasn't said it outright, is that there was a production password that was weak enough that could be admin or password that allowed them to brute force it and then use that for getting a bunch of different data and exfiltrating it out of that server. And I believe it was, I can't remember which one of these it was, but the Equifax one was very similar. 2019, this was one of the largest in history, and I was actually in the US when this was occurring, so I was part of this. But there was a vulnerability in an Apache Struts deployment that was known, but that Equifax hadn't patched. And so the attacker was able to get remote access to one of the servers. And from there, they were able to find, to discover, and take, and then use passwords for database users. All right, so now you have a password that was stored somewhere they had access to, so plain text or through some sort of configuration they could get. And now they have that password and they can use it to get whatever data they want. So when we talk about risk of a breach like this, right, it's the product of probability that something will happen and the impact if it does happen. So if we want to reduce our risk, we really have two different ways of doing it. We can try to reduce the probability, which usually takes the form of using fewer passwords, because if there are fewer passwords, it's less likely that one of them will be compromised. And we can store those passwords in fewer places. So even if we only have a handful of passwords in our architecture, if we give a copy of those credentials to all of our 100 developers, well, that's a lot of different places that can be breached. And so we reduce that to a minimum, and we reduce our probability. And we can use short-lived passwords, because that means that it's less likely that any credential that is breached at any given time is still valid and hasn't yet expired. So that, again, reduces our probability. And our other approach is we can reduce the impact if it does happen. Principle of least privilege, so using your minimum permissions model, only giving permissions to a role or credential that are absolutely necessary. Monitoring and detecting your breaches, so if it occurs, we can respond immediately, shut it down, and that minimizes the impact of that attack. And again, using short-lived passwords, if something does get taken, it minimizes the amount of time they can use it to cause harm. So in summary, passwords are risky. We want to minimize the use of them. And when we do have to use them, we want to minimize their scope. But if the topic is, well, we want to be passwordless, well, what do we use instead? And I'm sure most people in the room here are quite familiar with the 5 different primary authentication factors, so I won't go into a lot of detail there. But essentially, we have something knowledge-based, which is your password, something possession-based, so an MFA device or a certificate that's installed on a device, something that is inherent to the user, so that's usually biometrics, fingerprints, facial recognition, retina scan, speech or like voice detection. You have your location, which is primarily done through IP address, and behavior, which is the patterns of the user. So they usually log in at this certain time of day. So if someone's logging into their account at midnight, that's kind of weird. So we're going to flag that, or different types of resources that they access. And you can develop all sorts of machine learning models to try to detect those patterns and detect weird behavior with access. Now, in today's world of remote first development, and my developers are all over the world and they insist on being able to program from a beach in the Bahamas, we can't really use location anymore. It's kind of out of date in terms of an access control mechanism. And so our 2 most common currently are knowledge and possession, right? Password plus MFA. But what we're going to do here in this talk is we're going to get rid of the password and we're going to switch to something inherent, the biometrics. And between the inherent characteristic of our user and them possessing something, we have a multi-factor authentication system that doesn't require a password. And there are lots of different passwordless authentication technologies that have kind of come into development in the last decade or so. We have Windows Hello, which is kind of Windows' biometric FIDO2 capable system, Touch ID and Face ID for Mac, the FIDO Alliance with its U2F and UAF, and then FIDO2 specifications, security keys, all sorts of different toys we get to play with as developers to try to build something that's better. Now, for the basis of the architecture I'm going to propose, or that we'll look at as a case study, we're going to work with FIDO. A bit of background on FIDO. There were really 2 kind of capabilities that it started with. So there was FIDO U2F, which is universal second factor, and this was only good for second factor authentication. It only supported physical devices like security keys, only for second factor, and its idea or its intention was to replace one-time passwords. So instead of getting a text or an email with a code or using a time-based one-time token, we can instead generate that token from a security key or some device that we have and make it a bit easier. And then we had FIDO UAF and FIDO2, which is the new standard. And these support biometric authentication, which opens all sorts of cool doors for us. And they're designed as primary authentication mechanisms. So they're not just for second factor, they're for the entire login process. They replace passwords altogether. Now, FIDO UAF was part of the original standard. It kind of didn't really go anywhere. There were some competing interests in the original working group. Didn't really get any adoption, but FIDO2 has been exploding quite quickly and is pretty widely supported nowadays, supported by all of the major browsers and a number of other big players out there. A bit of an overview of the FIDO ecosystem. So this is a FIDO2 diagram here, and there are a couple different important parts. So we have the relying party, which is your application. That is what you are, the person who is relying on someone's authentication. And that takes the place of an application that is usually running in someone's browser, the client-side application, and then a server in the backend that's managing your credentials and other systems. And the FIDO2 aspects of this, there's really 3 of them. So the first is WebAuthn, which is described as an API. And when I talk about this with people, there's often a lot of confusion of like, what do you mean it's an API? Well, it is an API in your browser that is provided in the JavaScript, right? So it's a front-end API that allows you to interact with your browser, which then can interact with the host machine to work with Windows Hello or Face ID or some external authenticator. It is not an API that you build on a server. It is not an API that is hosted by FIDO2 somewhere. So that's what that means. And then we have CTAP, the Client to Authenticator Protocol, which is basically the system that allows your platform, which is what you're logging in or registering on, to communicate to some external device like my smartphone over Bluetooth or USB or NFC to use that external device as the second factor authenticator. So what the system does is it allows me to use my phone as a biometric device, so it has my fingerprint and it can store security keys on it, to register through my laptop with some external server that supports FIDO2. And then the third part is kind of that communication that you have to set up between your web app and your backend server to send and store the keys for your registration. So FIDO U2F and UAF, originally from 2014, didn't get a whole lot of adoption. People don't like carrying extra stuff, right? How many people actually have a security key and carry it around with them everywhere? There wasn't a lot of support for biometrics at the time. Infrared and 3D cameras were not very common on desktops and laptops. And developers are lazy, and you still needed a password anyways, so there wasn't a whole lot of motivation. But then in 2018, FIDO2 comes along, and this is where we start getting that complete replacement for passwords. And that convenience, that desire for being able to eliminate passwords altogether, actually gives us the motivation we need to go through the effort of trying to implement this. And we can use built-in fingerprint and face recognition on most of our computers now, or in phones. Windows Hello, Apple Touch ID, Face ID, they all support this. And it also has that improved CTAP2 support for external authenticators like your smartphone. And we can see that in 2018, we saw a spike in adoption of biometrics and for authentication mechanism because primarily of growing support for this. When we talk about how this is actually used for our end users, we can see that it's gradually getting some adoption. So on the left here, this is me trying to log into GitHub, and it gives me the option of using my security key as a second factor. This is using U2F or FIDO2 specifically for second factor. It's not using a passwordless replacement yet, but I assume that'll be coming soon. And on the right, this is me using a fully passwordless login into OnePass, which is kind of ironic because I'm using a passwordless system to access my passwords, but it does support that. So we're seeing adoption in the consumer marketplace. But the problem is that we're not seeing it in our own internal systems. And when we look at those breaches, when we look at those really large attacks, they're not some consumer or some user getting their account hacked, right? They're our developers and our credentials getting breached, and then someone having access to our entire internal database. That is where those mega breaches occur and where you're spending hundreds of millions of dollars to try to recover from them. So we're going to go through kind of a common architecture that we find in most infrastructure deployments, a lot of the really common components, and how we traditionally manage these things. So first, you're going to have an identity manager, right? This is often going to be Azure Active Directory or Google Workspaces. Those are the two most common these days. And these are going to include primarily an email service, such as Outlook or Gmail. They're going to include a login system, which is primarily email and password, and hopefully it's going to have a second factor for that, although far too often enterprises are not actually requiring this for their user logins. And to access our cloud system, in this case we're using AWS as an example, we have user credentials, which are very long-lived. So in this image here, we have, this is an IAM user dashboard, and you can see that these are credentials where the keys were created some almost 2.5 years ago, and they haven't been rotated, and they're still active. Very long-lived credentials. And they often have very expansive permissions, because these, if you've ever worked with AWS, it's actually very difficult to find a minimum set of permissions that do everything that your workflow might need to accomplish. So it's quite common that the people setting these up will just give them admin star permissions, and they can do anything. So now you have a long-lived permission, a long-lived token with very expansive permissions, and this is something that is stored locally for each of your developers who is using it. I showed you that AWS credentials file at the beginning. Everyone who works with AWS in a company is going to have something like that if they're using this kind of deployment. We're going to have a VPN, which is traditionally going to use a username and password or a certificate to authenticate to it. Either way, that's a long-lived secret. The password or certificate, probably not rotated very often, and is going to be not a short-lived token in any case. And most organizations don't actually handle certificate revocation properly, at least not the smaller ones, even if they're working on highly sensitive stuff. So this becomes quite a risk, because someone leaves the company, if they still have that certificate and you're not managing your certificate revocation properly, they can still log into your VPN and cause all sorts of problems. We're going to have a database. In our example, this is going to be MySQL. And the user and password, they could be rotated, but realistically, again, most organizations aren't doing that, at least not the ones that I've been hired to help. and therefore they are long-lived passwords. And it's also quite common that a single database user will be used across many different applications and services because it's just too much work to create different users for each application and to scope their permissions appropriately. So you have one user that can access a whole bunch of things with a password that isn't being rotated and is probably stored in a bunch of different environment variables somewhere. For our code repositories, we're going to use GitHub as it's the market leader right now. Again, username, password, long-lived. And the other thing is they're often outside of the organization's control. Because of GitHub's specific design, you're often inviting someone's personal account into your organization, and you don't have control over their password policies. You can require 2FA, but you cannot require anything else, really. So even if your organization wants to do better, they don't necessarily have the power to do so. And access to GitHub is to the code repository is much more sensitive than it's often considered to be, because as much as we all love to say we code review everything and every change is going to be verified and checked by several people, more often than not, something can slip through quite easily. So anyone who can even get into a development branch can get something promoted up into production, theoretically, and cause all sorts of problems there. And this is kind of related to what happened with the CodeCov hack. Also, having full access to your CI/CD system is pretty high risk because this is something very common in GitHub Actions, which we're using for our CI/CD system. You have to have secrets that your system can use for deployment. These, you'll probably recognize, are the same keys that were in that AWS credentials file. These often have admin permissions, and those keys are stored in many places. They're very long-lived, and it's very easy to leak them through the workflows and pipelines. As we can see through CodeCov, Travis CI, they can leak out. And they have pretty extensive privileges because it's hard to scope them. And it's also hard to rotate them because as soon as you're storing something in some other automated system, if you want to rotate it, now you have to rotate it in GitHub, rotate it in AWS, rotate it everywhere else it's stored, and try to sync this up. Like what happens if there's a workflow that's running when you try to rotate it, and now that's going to fail, now you need to rerun it, and it's just a pain. So people just don't do it. And it's hard to trace it if something goes wrong because when something's running in an automated fashion, you can't always track down who is at fault for instigating that. And I often hear, well, that's just how it is, right? Because how do you solve all these problems? And my argument is that's how it used to be, and we don't need to do that anymore. So we're going to run through this whole infrastructure again, but this time in a completely passwordless design. And we're going to focus on three main things. The first being that we're going to have a single source of truth for our users and their permissions and what they should be able to access. We're going to have group-based permissions for everything, and we're not going to have a password anywhere in our design. So let's start with that first component, your identity manager. In our example, we're going to go with Azure Active Directory. The reason being that it supports passwordless authentication for end users. As you can see with the highlighted red box there, this is allowing me to sign in with Windows Hello, which supports biometrics and FIDO2, or a security key that can do the same thing. It supports fingerprints, FIDO devices, face recognition. Some of them can do voice recognition. It includes the email and calendar that we want, etc. And it's important to note that Google has announced that Google Workspaces will be rolling out the same feature sometime in 2023. So that should be coming out this year if you're a user of Google. For our AWS credentials, we're going to use an IAM federated identity provider. And what this allows us to do is with SAML or OIDC, we can configure this to use Azure AD as our external IDP. So now we don't have users in AWS at all. We only have roles that can be assumed through trust policies by different groups. So we can have a trust policy on a role that says that this role can be assumed by anyone who's in the AWS admins group in Azure, or what other group you want. So you can have front-end developer group, back-end developer group, etc., and have different roles attached to each one that they can assume. Generally, this is an IDP-initiated flow, which isn't always great. You have to kind of access it through Azure or Google or whatever you're using. But you do have passwordless users who have passwordless AWS access. And since it's a hot topic that Amazon is pushing really hard right now, Identity Center, just to touch on that, is essentially a wrapper for the identity providers and the IAM roles that kind of manages them all for you. And it's designed to be for a multi-account architecture and to do that nicely. It definitely has a very improved UI. It has SP-initiated login, which can be quite nice. But big downside of thinking of using this is that it requires user and group provisioning and synchronization with your IDP. So whereas the IAM identity provider, it just redirects you to your IDP, you get sent back with your token or your access code, which you get a token from, it doesn't actually provision you as a user. It just gives you a role based on the claims in that token. But if you use this system, it doesn't do that. You actually have to provision all of your users in the database first, and it uses your roles in the Amazon database, not in your IDP database. So if there's any sort of breakdown in the synchronization process, say you remove someone from a role in your IDP, but that doesn't sync to Amazon's database, then when your user tries to log in, they can still access the credentials of that role they used to be in. So just something to keep in mind if you want to use this. For our VPN, we're going to use AWS's VPN client. It's based on OpenVPN with a bunch of customization. And we can link it with an IAM identity provider or through Identity Center, which gives us single sign-on access. So now we have that link to Azure AD as well. And we can configure our client VPN with authorization rules that link to user groups. So we can say that when you're connected to the VPN, if you are in the developer role or junior developer group in Azure, you are allowed to access the development subnets and the test subnets, and that is it. And you can say that if you're in the administrators group, you can access those plus the production subnets, and you can kind of split up your network access based on roles that they have in your identity provider. So now you have VPN access that is passwordless, and it's linked to your Azure AD groups. For our database, we're going to use Amazon RDS, which supports what they call IAM authentication. And so instead of actually creating your users with passwords in your database, you create them and you say that the authentication is going to be handled by Amazon's plugin. And this allows you to create a bunch of different users in your database and then have your IAM policies that allow users to assume those users in the database or to connect as those users in the database based on what group they have in Azure. So now you can say that my junior developers can access my database as like development user, but not the production user, and you can set up all sorts of permissions based on roles again. Or you can connect them to roles that your code is running as, when it's in a server in Lambda functions or ECS or Kubernetes or wherever it's running. And because it's linked to Identity Center, which is linked to Azure AD, again, you have passwordless all the way through. Now, this does generate a very short-lived token. The way the system works is that you use your role to generate a temporary database password, which only lasts a couple minutes, and you send that to connect and then discard it. And it does require a little extra work because that token rotates quite quickly. Every time your connection pooling software wants to create a new connection, you have to be able to dynamically generate a new connection string. So it's a little bit tricky, but most of the packages support that kind of like a callback or hook in there to be able to dynamically generate the password. For GitHub, we're going to use GitHub Enterprise because it supports SAML. And you can link it with our Active Directory again. And so now our repository and CI/CD access is based, again, on our Azure groups. So you can say that people in this group get to access or read access or write access to this repository, and so on. You can set up all those rules in a way that is tied directly to your user groups and not to specific users. It doesn't require any password to access it. And for the secrets, now this is probably my favorite element here. We're going to use GitHub Actions again, but instead of storing our credentials in secrets, we're going to use GitHub Signed JWT. Now, this is a feature that they released within the last year. It's relatively new. And what it does is when you run a workflow, it actually creates a JWT for you that you can access in that workflow. And it is signed by GitHub. And it includes claims for the repository, the branch, the tag, and a bunch of other information you might find interesting. And then in Amazon, in IAM, you can set up an identity provider which trusts GitHub as the signer of that JWT. And then you can create IAM roles that have trust policies that tie into these different claims. So you can say that I have this role for my development front-end deployment, which allows the front-end repository on the development branch to assume this role. And you can scope your permissions very small without having to manage any secrets within GitHub Actions. The only thing GitHub Actions needs to know about is the role that you want to assume, and we don't consider that to be a secret. And this was actually interesting enough to me when I was learning about this when it came out about 6 or 7 months ago, I think, that I built an open source Terraform module for it. So if you're interested, you can take a look and see how that works. And it allows you to, from within Terraform and AWS, set up a repository and permissions for it and a role that can be assumed by it. And then you can use Amazon's custom action within your GitHub workflow to get that credential without having to store anything in your GitHub secrets. So in summary of our architecture, we have identity user management, we have a VPN, databases, code repositories, CI/CD, and there isn't a single password to be found anywhere in this entire infrastructure. And I'm going to pause here for a moment because I'm curious to hear questions or challenges, I guess, of where would this not work? Does anyone have any comments or questions about where you'd want to hear how you could do some other Amazon service or some other piece of software in a passwordless fashion? Okay, I guess I'll take that as I've convinced you that you can do it with anything. And the last part I want to talk about is selecting vendors, because this is an important part, especially for those of us who are in tech leadership roles or management roles, and we're tasked with helping to try to choose which pieces of technology we want to use for our product. And there are a couple things I want to point out that we should keep in mind. The first being that we always want to look for SSO support, so OIDC or SAML, in supported for the logging in of whatever third-party service we're trying to use. And similarly, we always want role or group-based permissions, because as I've been harping on this entire talk, we never want to assign something specifically to a user because it becomes a nightmare to try to manage when you have hundreds or thousands of users. And the other big point is that we want to look for providers that offer security features at no extra cost. And things to avoid are essentially just the opposite of all that. Anything that doesn't offer SSO support, user-based permissions, or services that charge a premium for security features. And the reason I talk about security features here is that, in my opinion, security is a shared responsibility. It is the responsibility of the provider to give us the tools we need to use their system securely, and it is our responsibility to actually use them. I love Terraform. I use it all day, every day. I've dabbled with Terraform Cloud a bit, and while I liked the product, this really threw me off. A couple things to note here. Team management is under the paid plan. So they have a great free tier, and as we all know, if there's a free tier, then companies are going to do everything they can to remain under the free tier and not move to the paid tier. Team management is what allows you to have different users and groups with different levels of permissions. So if you're using the free tier here, you cannot have any user who is not a complete administrator. There's no way to restrict the permissions of any user. SSO is under the business plan. And if anyone's ever clicked this button down here, you know that that is a button you don't want to have to click. And SSO, as we talked about, is a core principle in trying to maintain security of your systems, because everything that you can log into with a federated identity is one less place where you're storing usernames and passwords than that you have to keep up to date. So these are big problems. I hate to give Terraform this kind of flack, but maybe they'll change their pricing one day if they watch my talk. When there's no other option, and there will always be cases, at least for the foreseeable future, where there's no other option, you have to use a password. Always use two-factor authentication. I think it's like 99.9% reduction in the risk of an attack when you use 2FA. Like, it's a small thing that gives a massive impact. Rotating your passwords is not always easy, but a lot of the tools we use to store passwords have this kind of feature built in now. And it does take some coordination to make sure that anything that's using the password when you rotate it doesn't crash and fall apart, but it's doable and it's definitely worth the investment. Randomly generate passwords, of course, and then keeping your tokens for external services in vaults that are only accessible by the applications that actually need them. So if you have a password that your application needs, but your developers don't actually need it, don't let your developers access it, because every fewer point of access, or every less point of access, is somewhere where it can't be attacked. And furthermore, if you can, load these secrets at runtime and don't store them anywhere, because when we're talking about reducing the probability of an attack in order to reduce your risk, one of those items was minimize the number of places where secrets are stored. And so if we're storing them in environment variables or configuration files or anything that's part of a code base or that is stored somewhere in the cloud, each one of those is surface area. And if we can load them at runtime instead from a central vault, we avoid a lot of that risk. If a password must be shared, yeah, password managers still are the best option. Certainly better than pasting it in Slack and then forgetting to delete it afterwards. So with that, I'm a little early, but thank you. And that covers the passwordless cloud architecture, and I'm happy to take any questions. And this is my email, so feel free to email me with any questions if you have any. I can repeat your question. He's bringing it up now.
Thank you. So I wanted to expand on the last section of choosing the vendors, and even in your talk you mentioned like, oh, like we need to select GitHub Enterprise, so which is kind of like extended features, and smaller teams and smaller organizations don't have it. And if we put GitHub out of the question, is there any calculations of cost if you start using all these features from AWS? Does it cost more to run your infrastructure?
So everything that I mentioned on the AWS side, those features don't add any cost at all, because what you pay for with AWS is compute time and memory time, basically, right? So anything that doesn't take additional compute time doesn't cost anything more. And the one thing that I do really like about AWS is that their security features are generally no extra cost or a minimal extra cost. So no, to implement all that in AWS doesn't cost you a dime. In terms of GitHub, yes, so the reason I was okay with putting the GitHub Enterprise up there is because they actually publish the prices, and the prices are not ridiculous. And it comes with a bunch of other features that large companies or tech companies will probably want anyways. There are cases like Terraform Cloud, like there was a conference I was at a couple months ago where we talked about this with one of the vendors, and I made that same argument, and he promised me he would change the pricing, and then he didn't. But like it's a very common thing to put SSO under the enterprise package, which I strongly disagree with, but that's just how it is. So it's always a trade-off, right? Like how much do you value security versus how much money do you have, right? The more places you can get rid of it, the better.
I'm not very experienced with AWS, but I heard like even the secrets manager, you have to pay for each secret stored in the secret.
Yes, you do. But with a passwordless architecture, there are no secrets to store. So you don't need to store any.
I mean that thing which rotates your password.
Yes.
Oh, okay.
That you do have to pay for.
Okay.
You can build your own thing. Like there are other services like HashiCorp Vault. There's something in Kubernetes that does the same idea. They all have their offering for a given type of infrastructure. That's just Amazon's managed one, which I use as an example.
Thank you.
No other questions? So, yep.
Hi. Oh, that's a little loud. Thanks for the talk. Super interesting. You had a slide there about selecting a provider if you need some third-party service to integrate with your application. If we flip that around, though, and you're working on an application where you want to become a third-party provider, how do you look at choosing the right protocols or choosing the right ways to allow other applications to integrate with yours?
That is a great question. A lot of my clients are business-to-business clients, right? So they're doing that exact type of thing. And one of my clients last year was doing exactly that, and they had dozens of businesses that wanted to use their own corporate SSO as federated IDPs. And we had a problem. Before I came in, they were using Auth0, which was going great, except they have a hard limit of 3 external IDPs that you can set up. And we argued back and forth with them about it, and they said, no, you need to pay the $30,000, $40,000 enterprise plan or whatever it is. And eventually we just gave up and moved to Amazon Cognito instead, because you can do an unlimited number of external providers. So if you're offering an application like this, then there are options you can choose where there is no added cost to implement federated identity. So Cognito is a great example, simply because they don't charge you anything for external providers. And in terms of what protocols to use, well, fortunately, we have a lot of standards. Currently, I would recommend OIDC. as the leading technology in the federated identity space. SAML works, but it's outdated, and there are some security risks that aren't present in OIDC when you're using an explicit flow. And FIDO2, also a standard that is being very rapidly adopted. So go with what is currently the standard and offer that ability to your customers, and they will absolutely love it.
Awesome, thanks.
Okay, I think that's all. Thank you all for coming.